Here is my final project for CSE 564 visualization course. I used D3 to visualize the temperature change around the world over the last 100 years. The main deliverable is an interactive world heat map. The surface of the whole globe is divided into 16,000 grids according to longitude and latitude. The color of each grid represents the temperature anomaly of that small area in a given year. By saying temperature anomaly, we are referring to the relative temperature compared to the average temperature during the period from 1951 to 1980. So the heat map does not indicate the temperature of red grids is higher than the blue grids. Instead, the red grids is hotter in this year compared to the average temperature in that area, and the blue grids is colder. The gray grids are where we do not have the temperature measurement data. The line chart below the heat map is the temperature anomaly trend from 1880 to 2016. The red line indicates the global average anomaly. We can clearly see that our globe is about 1.2 degrees Celsius higher than it was 1 century ago. We can pick some years to see how the temperature anomaly was distributed around the world. We can do this by clicking in the line chart to select a year. Let's select a relatively cool year, 1956. We can see that most part of the world is blue. That means that in that year most areas on Earth is colder than average. It is interesting noting that most of the dark blue spots are on continents. In contrast, the temperature anomaly over oceans is relatively minor. Now we select 1998, a relatively hot year. There are red grids everywhere. And again, the anomaly on continents is more obvious than oceans. This is explainable, since large amount of water in ocean can act as heat buffer that can smooth the temperature anomaly. This means that land is more affected by climate change than ocean. However, a small part of the Pacific Ocean here, west of Peru, is relatively hotter than its surrounding areas. If we are interested in a specific region, we can select it by drag create a selection window over the grids like this. The text in the window indicates the boundaries of the window and its proportion of surface area in the whole globe. When the selection is finished, a new green line is drawn in the line chart below. It shows the temperature anomaly trend in the selected region. The trend of this specific region is much more oscillating than the global average. If we look closer, we can see some periodic patterns every 5 to 10 years. This is a very unique pattern that is not observed in other ocean regions. If we select a region in West Pacific region, the trend is smooth. Indian Ocean, smooth. Northern Atlantic, still smooth. Actually, the temperature oscillation in Eastern Pacific is called El Niño Southern Oscillation, and it is responsible for the well-known El Niño and La Niña phenomenons. This kind of temperature anomaly can cause extreme weather all around the world, and is becoming more powerful and frequent in the last few decades. If we select a hot year, like 2010 or 2015, we see that the color near the Arctic region is much darker than anywhere else. Does this mean that Northern Hemisphere is becoming much hotter than other regions? Let's select the region north of 30° north. We can see that although the temperature anomaly trend of this region aligned with the global average before, it is now higher. If we select the equatorial region, we can see that its temperature anomaly trend is very close to global average. If we select southern region, we can see that the green line falls below the red line. So it is true that northern region is more vulnerable to climate change. Please note that all the temperature we are talking about is the anomaly compared to average. So this does not mean that the temperature in northern hemisphere is higher than southern hemisphere. Temperature in both northern and southern hemisphere is rising year by year. It is just that it rises more in the north. One major consequence of hot weather in northern region is the melting of Arctic ice sheet. Here is the cyclic line chart of Arctic ice sheet volume in every month during the last 40 years. Each data point is the average volume in a consecutive 5 years period. It is clear that Arctic ice sheet melts down during summers and is rebuilt in the winter. However, less and less ice is rebuilt than melt. This makes the line chart into a spiral. In most recent years, There is almost no ice in Arctic area during summers. I hope you learned one thing or two about climate change after watching this video. If you are interested, you can play with it yourself on my website. The link is given in the description below.